Hello everyone, my name is Jagdish Babalsure and I am currently studying in third year at MIT Academy of Engineering Alandi, Pune. This video is a part of my academic work and I am presenting it under the guidance of Dr. Vaishali Wangikar ma'am. I would like to thank ma'am for her continuous support and guidance. Today I will explain gradient descent and the optimization of the best fit line in a very simple and easy to understand way. By the end of this video you will clearly understand what a loss function is and what mean square error means. Coming to introduction, in machine learning the main goal is to make correct prediction. For example, predicting the price of house, predicting the salary of employees based on experience, predicting marks of students based on the study hours, and many more real life example. To make such prediction, the model has to learn patterns from the given data, and to learn those patterns perfectly, the model needs a method to reduce errors. This method is called optimization, and one of the best optimization techniques is gradient descent. Coming to regression, now let's talk about the regression because the gradient descent is mainly used in regression for understanding the relationship between two variables. The regression is basically a technique where we try to draw straight line that best matches the trend in the data points. This line help us to predict the future value. The formula for the line is y equal to mx plus b, where m equal to slope of the line. It tells us how fast the value of changes when x changes. B is the intercept, the point where the line touches the y-axis when x equal to 0. X is the input and y is the predicted output. Job of machine learning is to find the best possible m and b so the line fits our data correctly. Why do we need a loss function? Whenever we build a model, it gives prediction, but the predictions are not always accurate. They will some difference compared to the actual values. They give might wrong answers, like a loss function help us to measure that difference in actual value or predicted value. Think of the loss function like a teacher checking our exam paper. If a lot of mistakes we have done, we get a low score, and if we get a fewer mistake, we will get a high score. Similarly, high loss equal to bad model, and low loss equal to good model. The loss function tells us the model how wrong it is to the do that. It will learn and how it will improve. Our aim is to reduce a loss function such as much as possibly so the prediction becomes accurate. In regression, we usually use something called a square error loss because it increases the penalty when the model makes large mistakes. Mean squared error. The most commonly used loss functions in regression is the mean square error or MSE. Mm, First, in MSE, we calculate the difference between the actual value and predicted value. We square the difference to remove the negative sign and to give more importance to bigger errors. We add all the square errors, and finally we divide the total number of data points. As mathematically, this is written as j, which represents the cost or loss of our model. Our goal is to make j as small as possible. What is gradient descent? Gradient descent is a powerful optimization algorithm. Uh, it is used to reduce the loss function. Imagine you are standing on the top of mountain. and your goal is to reach the lowest point in the valley. You cannot see the entire mountain, so the only way to reach the bottom is to look around and find the direction where the ground goes down the most. When Then you take a small steps in that direction. After that, you again check which direction slopes downward and take another steps. You repeat this until you reach the lowest point. This is exactly how gradient descent work. In our problem, the mountain represent the loss function, and the lowest point is where the loss is minimum. The steps we take are updated to M and B. Gradient descent keeps checking the direction in which the loss decreases the most and moves in the direction. With each steps, the values of M and B better and better, reducing the loss. Finally, after many iteration, the gradient descent reaches the minimum point, and that is where we get the best fit line. Coming to how gradient descent works, firstly start with any random values initialized to M and B, and then predicts the output by computing the formula mx plus b. Calculate the loss using the MSE formulas. Compute the gradients. This tell us the direction in which the loss increases or decreases. Update the M and B in the direction that reduces the loss. Repeat this again and again. This process continues until the loss becomes as small as possible. Coming to gradient descent formulae, these formulae show how M and B get updated in every iteration. Partial derivative tell us how the loss changes with respect to the M and B. Using these values, we adjust B, M and B. After enough iteration, the values settle at the base point, and the line becomes the perfect optimize. Coming to the learning rate, written as alpha control how big or small the steps are during updating. If the learning rate is too small, the learning becomes slow. If it is too large, our algorithm may overshoot the minimum and fail to converge. So choosing the right learning rate is very important. It decides how fast gradient descent finds the best fit line. It tells how the model will predicts. Coming to the example, how the gradient descent find the best fit line. Here is a we uses a house size and price steps using the house type data set, where green dots uh, tell us actual data points, and the purple line describes about the best fit line, and the error is describe how it is prediction errors. Firstly, we start with mn0, m0 and b0. uh, then calculate the predictions, compute the loss, calculate the gradients, adjust M and B slowly. After many iterations, loss becomes minimum. At this point, we finally get the best fit line. This is how the descent help us to find the most accurate model. So it finds the best accurate fit line that passes as many as possible actual data points. The cost convergence, during gradient descent, the cost or loss decreases with iteration. In the beginning, the loss is high. As we update M and B, the loss keeps decreasing. Finally, it reaches at a point where it cannot reduce anymore, uh, where we mark as a stars. You can see it here. This is called convergence. The graph shows the graph shows on the x-axis. The graph shows iterations on x-axis and cost on y-axis. You can see the curve going down and then flattening at minimum point, and then it goes up. So it curve decreases as flattened as minimum value. Here, in conclusion, the loss function evaluate model accuracy. The loss function measures the accuracy of our predictions. MSE is most commonly used used loss functions in regression. Gradient descent is used to minimize the loss and find the best value of M and B. Learning rate controls how fast we reach the minimum loss. Finally, we get a best fit line that perfectly matches the data trend. Data trend. As a result, we find the best fit line with the minimum error, where as many as data points can pass through it. Thank you for watching this video. I hope you understand the concept clearly.